let's hope this works. So this particular problem, let's analyze it like any stoichiometry problem. We have our starting amount, which is the 27.1 grams. Of what, though? What's the formula? 27.1 grams of? Everyone's afraid to say anything. Benzoic acid, thank you. Okay. So 27.1 grams of benzoic acid, and we're being asked to calculate moles of water. All right. So notice I underlined the starting amount, and I underlined the ending unit that we're going to. And we're probably going to want to figure out the path through the mole map that we're going. We're starting with grams, and we're ending with moles. But we're not ending with moles at the same side because this starting amount is grams of benzoic acid, and we're not ending at moles of benzoic acid. Otherwise, we could have done this back 2 chapters ago. This time, we're ending with moles of water. So if you look at the mole, this entire side of the mole is benzoic acid. By the way, that's in soda. And the end of the mole is all water. So anything on this side of the mole, grams, particles, liters, we're talking about water. And anything this side of the mole, particles, liters, we're talking about benzoic acid. And the thing that connects the 2 sides is the mole ratio. Yeah, good. Okay, so the path that we're doing, I'm going to draw it in a different color. It's from grams to moles. So we're going to have to do that. That means we're going to have to use the mole ratio. It also means that we need to use the molar mass. Molar mass of what? Benzoic acid or water? Benzoic acid, yeah. All right, so like I just said, we're going to need to do a number, a unit, and a substance everywhere. We're going to set this up as 27.1 grams of benzoic acid. I'm going to be a little lazy here, so I'm going to write HBZ, which is a nice chemistry abbreviation for benzoic acid. Actually, maybe I shouldn't be that lazy because I'm forcing you guys to write the whole formula. So let's write it all out. C6H5COOH. Wicked tasty. That's what you're drinking when you're drinking soda. Anyway, so we got this right here. And so the very first thing we're going to need to use is we're going to need to use the molar mass of benzoic acid, right? Because by using the molar mass of benzoic acid, we get to moles. If in doubt, roll it out. Thank you. So we need to use the molar mass of this. All right. By the way, notice I have not yet balanced the equation, right? Right. Even if I balance the equation, and by the way, when you balance the equation, you get a 2 there. Don't multiply the molar mass by 2. That's really, really important. It's the molar mass. Molar mass literally means mass of 1 mole, not 2 moles, right? That means 2 moles. So that would be the twolar mass. It's not the twolar mass, it's the molar mass. So when we add that all up, and hopefully you guys are good at doing the molar mass at this point, it's actually 122. Does anyone raise your hand if you want me to go through how to do that? I will. Yep. All right. So you look up the elements on the periodic table. Carbon weighs 12, and there's 6 of them. Remember, you always multiply by subscripts. So it's 12 times 6. You look up hydrogen on the periodic table. It weighs 1, and there's 5 of those. Okay, every time you switch an element, you add because they're next to each other. They don't multiply, they add. There's another carbon. Yes, it's written a little weird, but there's another carbon there. And then there's another oxygen, and then there's another oxygen. So we're just adding up. Every time we switch an element, we add up. And then finally a hydrogen. So 12 times 6 is, I think, 72, plus 5, plus 12, plus 16, plus 16, 32, plus 1. And so we could do all the math. It should come out to 122. And the unit should be grams because it's a mass. So units are grams. Okay, that's the mass of 1 mole of benzoic acid. Means if you have 122 grams of benzoic acid, you have a mole. If you have half of that, if you have 61 grams of benzoic acid, you have half a mole. But that's a mole. Back 2 units ago, we would have left the fraction like this. But in stoichiometry, it's really important that we know what we're talking about. We're talking about benzoic acid. That's why we write C6H5COOH. Yes, it's annoying to write the whole thing out over and over again. Technically, it's not really important to write it here, but You should. Okay. If we ended our problem here, the unit of our answer would be moles of C6H5COOH. Is that what we want as our answer? No, we want moles of water. Moles of water. Okay, now we need to go and we need to do the mole ratio. The mole ratio is the ratio of C6H5COOH to H2O. Why? Those are the two things talked about in the problem. We don't care about the carbon dioxide. We don't care about the oxygen. They're in the problem, but we don't care. We need a balanced equation to do that. Like I told you earlier, the equation is not actually balanced at the moment. Does anyone want me to go through balancing the equation, or do you just want me to give you the answer? Anyone balance the equation? Nope. All right. So it's 2. It's, what is this? 15, 14, and 6. That's the balanced equation, which means the mole ratio is the ratio of benzoic acid to water in the balanced equation. In other words, 2 to 6. All right, we're going to put the benzoic acid on the bottom, 2 moles of C6H5COOH, and then we're going to put 6 moles H2O. That's the molar mass, or sorry, mole ratio. And it comes from the balanced equation. And again, we pick the two things from the equation that we actually care about. We don't care about oxygen, we don't care about carbon dioxide. In another problem, maybe we would. We don't care here. All right, if we stopped here, let's cancel. We're canceling C6H5COOH. That goes away. The substance that's left over now is water. So that means the answer that we get at this point is moles of H2O. Is that what we want? Yeah. So that'll be our answer. And our answer, we're going to multiply across the top. So we're going to do 27.1 times 6. We're going to multiply across the bottom. We're going to do 122 times 2. And then we're going to divide those two numbers to get our final answer. And the final answer is 162 grams water, H2O. Notice I wrote a number, a unit, and a formula. All right. Out of curiosity, what if this problem was different? What if this problem didn't say moles of water? What if this problem said grams of water? What would be different about our math? Yep.
You'd have to do another ratio after.
Right. Exactly. You just do one more ratio. Instead of stopping at moles, we'd go one more step to grams. We'd use the molar mass. We'd use one more ratio. So the ratio we'd use this time is the molar mass, but not of benzoic acid this time. This time we would use the molar mass of water. And the molar mass of water is 18 grams. Does 18 grams go on the top or the bottom? Top. So 18 grams H2O. The reason it goes on the top is 1 mole H2O goes on the bottom, so moles cancels. And then we would get, in other words, we would just, oh, I made a mistake, I'm sorry. I made a mistake. I gave you guys the answers to the previous problem. That's the answer number 5. It's not 100, because why didn't anyone stop me? You know, this isn't moles. Right? That's not moles. Nobody stop me, come on. Help me out, I'm being recorded here. So the answer was 0.666 moles H2O. And by the way, if we had done this whole thing out, what's 2/3 of 18? I think it's 12. So if the problem had been grams of water, it'd be 12 grams of water. All right, I'm going to stop the video now before I embarrass myself any further.